Hello and welcome to another video. In this one we're going to be talking about Docker beside Docker. Now some people incorrectly refer to this as Docker in Docker, which is a different way to run nested containers. So I'm going to explain how this works and why it's not actually nesting containers, but I'll show you how it works and some caveats about it as well, especially around file mounting. But anyway, let's jump into it. Okay, so we're going to be working with Docker today. So I have my other virtual machine, which still has Docker installed. It also has Podman installed, but we're going to be working with actual Docker today. And the way that Docker works, or at least the, I guess we can open up Paint and talk about this. The way that you can think about this is there is a special system daemon running called Dockerd. And Dockerd listens on a API, it's kind of RESTful, a RESTful API, and it does that over a Docker socket. So somewhere on your machine, it's usually at var run docker.sock. Yeah. So you can see that there is this root Docker owned socket here, sitting here at var run docker.sock. var run docker.sock. And what you can think of a socket file as, or at least how I think about it, is it's a file that represents kind of like a web server. It's not exactly how it works, but it kind of works like a, like an HTTP endpoint. It's not exactly that, but that's how I think about it. And so you then have a client. So this is all in, where do we draw our line? We can use this color. So this is kind of the separation between like privilege space, and down here we have like kind of our user space. And so whenever we want to interact with Dockerd, whenever we want to run a Docker command, we use the Docker binary, which we can call here. So let's say that this is Docker, and we might, invoke Docker run Ubuntu Focal or something like that. And what that's going to do is it's going to communicate to this Docker socket here, and it's going to say, I don't know, pull container. It's gonna say something similar to, pull Ubuntu Focal and then run container and, communicate standard in / standard out, etc. And that's roughly what it's going to do, but using a socket API, using HTTP-like calls. And Dockerd is then going to run off and spin up our container here. This is going to be our Ubuntu Focal. And again, this is in privilege space. This is how rootful Docker works with a separate daemon process. It's going to start our Ubuntu Focal container over here. And I probably should have used a different color for containers. Maybe containers will be this light blue color. Sure. And so this is our Ubuntu Focal, which is running, I don't know, bin bash or whatever. And that was in response to communicating with this socket. And then any outputs that happen from this process here are going to be funneled back through this socket to this command here. So they're kind of funneled through the socket. So you kind of, communicate and get a response. Communicate and get a response. That's how you can think about it. So this is kind of how Dockerd works. And so I want to show you Docker next to Docker, where you're actually running Docker commands inside of this container here and spawning new containers as a result. And the way that tends to work is you mount this special socket into this container, and then this container can interact with that socket in the same way that this unprivileged user can interact with the socket. Now note, Docker in this configuration, and if you give your containers access to this socket, they can do basically anything on your computer. They can break out of the container, they can run other containers, they can, they live in privileged space, so they can do privileged things. But let's do a quick demo of that. I have two images pulled already. I have Ubuntu Focal, and I'm actually going to use this this container instead, or this image instead, which is Docker latest. This is a container which contains a Docker binary, so I will be able to run Docker stuff inside of a Docker container. So let's see, Docker run, and always do rm ti so we can interact with it, and Docker, I don't know if it has bash. We'll try bash. We might have to use sh though. Nope. Container does not have much in it, but it does have Docker, and you'll see if I run Docker off the bat without any special arguments, like if we want to try and run Focal in here, you'll see that it hangs for a little bit and then should error. You might have to go through the full TCP timeout, so I don't know how slow it's going to be. But it's actually trying to find a Docker socket right now and connect to it, and it's unable to do that because there's no Docker socket. So this is going to fail. I'm just going to Control-C it to skip that. Now what we can do is run Docker beside Docker, where we can mount that Docker socket that I talked about earlier inside the container, and then the container can spawn other containers. Oh, I should have showed you here Docker PS while that's running, so you can see we have exactly one Docker container running. That's this one here. So now if we mount that Docker socket in with volume, var run docker.sock, and mount that to var run docker.sock. I think we need read write so that we can interact with it. And now if we do docker ps again, you'll see we still only have one container. But now if we run docker run focal, you'll see that we're able to what looks like running Docker inside of Docker. But what actually happened, if we go back to this diagram here, last video, what we're actually doing here is we're communicating through this socket and spawning another container beside this one. So instead of this Focal container, pretend this is the Docker container, and it has now spawned another Focal container. And we can actually show that by doing docker ps here. And this is docker ps outside of that container. You can see that we've actually spawned two containers side by side. Now it looks like it's Docker and Docker, but it's not. it's again communicating over that socket and spawning a new container outside of the original container on the host. Yeah. And the reason this was brought up on my stream is someone was asking about file mounts, and interestingly enough, I actually had just implemented something similar to this in pre-commit, which has to deal with mounting files in Docker containers and potentially running in this Docker beside Docker configuration. And if you're doing another call inside of this container, you have to be really careful about where the file mounts happen from, because this Docker interacts with Dockerd outside of that container. So this Dockerd only knows about your host file system. So if you had written some file inside this inner container here, there's no way the Dockerd is going to be able to find that. Let me just demo that really quickly. So if we touch foo, for instance, and we do, actually, let's put it in. We're gonna put it into temp just so I don't write to the root of my file system, because this is actually going to cause a directory to be created if I don't do that. Oops, right, this is sh, and let's actually put something inside of foo so that we know the difference. If I were to run docker run and mount as a volume temp/foo to temp/foo, read only, sure, rm ti unto focal bash, this is going to successfully start the container. And if we look at temp/foo now, you'll see that it's now a directory, despite it being, you know, a file that contains the contents high here. And this is because what Docker has done is it said, oh, I don't know about temp/foo. It has gone ahead and created a directory on my host machine, and you'll notice that it is owned by root, and that is because Dockerd again runs as root. So it created this directory and then mounted that root created directory into the container. It did not mount the file inside of our container here, because that's in a completely different file system here. So if we put this on our diagram here, I select tool. This is actually our Docker, oops, blue text on blue background. Yeah, that's totally gonna work. This is our Docker. This is the Ubuntu Focal that we created. This has a thing at temp/foo which contains hi. And when this spawned this container here, what it did is it communicated out through this socket to Dockerd. Dockerd made a temp/foo directory out here, and then it mounted that temp/foo directory. I guess I should put a trailing slash here so that we know it's a directory. It then mounted that temp/foo into this container here. So that's why it didn't do what we expect, and this is what it actually did here. Now we can kind of work around this. We can kind of work around this, but it requires us to mount something into the initial container, and that's the file system that we can then remount into the final container. So let's back out of these two containers here, and we're going to mount an additional directory in here. Let's just do the current working directory. So we're going to mount temp/explains into this first container here. And now if we cd to temp/explains and we touch foo, this is going to write foo outside of here. And let's actually put interesting contents into there. So that's actually going to write to our host file system. You can see that we can cat foo and we get a hi there. Now if we were to mount temp/explains, because it was mounted from the host, it's going to remount it into that other container. So it's kind of going to get dual mounted into both containers. And that's how you can pass file names that way. So if I do, or that's how you can pass shared directories that way. TIV twid Ubuntu focal, for example. And now if we do cat temp explains foo, you'll see that it contains hi. But again, this temp/explains is not the one inside the container. This is from the host. So if we, we're probably gonna have to use sudo here, yeah, because it's owned by root. Sudo, well, echo wat sudo t foo, and you'll see that it now represents that. Because now we have three containers, or we have two containers and the host that all have this same path here. Now, if you're mounting at different directories, you'll notice here that I use pidoed, so this expanded out to the current working directory. You might not mount it at the same location as your input, so you might have to do some special stuff to figure that out. So let's demo that example. So if we mount pidoed to, I don't know, /code, for example. Now if we look in code, you'll see that code contains this foo file. This code directory represents the same as this temp explains directory, but they're a different path. So if we were to try and mount /code, it wouldn't work again. We would have the same problem as we had with the first example, where Docker-D would be like, I don't know what /code is. I'm going to create that on the host machine, and then here's your empty directory that you asked for. Now we can actually work around this by asking the Docker daemon what mounts exist for the current container, and then translate our file paths based on that. But doing that is kind of tricky because you have to figure out from inside the container, what is my container name? And the easiest way to do this that doesn't work in most, or in all cases, is to ask for the host name of your Docker container. Host name. And by default, if you haven't overridden the host name, this will refer to your container ID, and so then you can do docker inspect hostname, and it'll tell you all about this container, including our bind mounts here. So you can see here that temp explains got mounted to /code. So if you knew that you wanted to mount /code into some other container, you could take the prefix of this, replace it with this, and then remount that into the next container. Now, like I said, hostname is not super reliable because you can set hostname on the command line here. So if you set hostname here, now I run hostname, you'll see that it no longer represents that container ID, and so it's a little bit trickier to get the container ID. The one somewhat consistent way that I've seen to find the container ID is to do proc1 cgroup. Yeah. And this will contain a bunch of stuff, but you can look for the Docker one. Right here. Oh, they all say Docker. Never mind. You can look for any of them that say Docker. And this hexadecimal string here is the container ID. So if we do docker inspect this, you can see that now we have again retrieved back the container ID. So this works whether or not the hostname is set. But yeah, that's kind of what I wanted to show you, and what's really going on when you're doing Docker beside Docker and mounting this special socket inside this container. Basically, giving the container access to the daemon API. But anyway, hopefully this was useful. If there are additional things you would like me to explain, leave a comment below or reach out to me on the various platforms. But thank you all for watching, and I will see you in the next one.